right, how are we doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. And today we are going to be talking about experimental probability of simple events. Before we start, I want to invite you to go ahead and subscribe, click the notification bell on and all that good stuff. And if you haven't subscribed to my other channel, I'm going to leave a card right here. You can check it out. I do mountain bike and DIY stuff. It's pretty fun, sometimes seeing the random stuff. It's pretty fun. And if you want to support this channel, link down in the description. Buy me a cup of coffee. So, experimental probability of simple events. Previously, we talked about theoretical probability of simple, compound, and also making predictions with theoretical probability. Now, the difference between theory and experiment is that theory, everything is perfect. And an experiment, you're actually hands-on. So even though the math might look great, on an experiment it's not necessarily going to happen, okay? So that's the only main difference. And basically at the end, you're going to have to use your common sense sometimes. So experimental probability is an estimate of the probability that a particular event will happen in. Just like on theoretical, it's about the same thing so far. It is called experimental because it's based on data collected from experiments and behavior. So, it is called experimental just because you're actually, like the video we saw the other day, like the guy was flipping a coin and he did it, I don't know, like 100 times. And he was collecting that data, that he was actually doing an experiment. That's what the difference is. You're actually doing the experiment and not just making it look good on paper to see what the theory is good. But the experiment is actually what's going to happen. So we have a formula, and just like before, it's going to be part over total. The formula is going to be the same thing. It says experimental probability. To find experimental probability, you're going to divide the number of times a particular event happens divided by the total number of trials. What does that mean? So if we're flipping a coin, and you're looking for tails. You're going to mark that, write down how many times, and you're going to do it 100 times, for example. You're going to mark down how many times you actually got tails out of the 100. So, for instance, on theoretical probability, the chance of landing tails was 1/2, one out of the two sides of the coin. Now, it's not necessarily going to be 1/2. It can be 1/2. It's going to be pretty close to 1/2, but it can vary, maybe a little bit less, maybe little bit more, because you're actually doing the experiments. You might get 48 times tails, or you might get 58 times, something like that, and it's all good, because this is the actual experiment. So, we have a few examples that we're going to be working on, and it says JT is practicing his batting. The pitcher makes 12 pitches, and JT hits 8 of the pitches. What is the experimental probability that JT will hit the next pitch? Now remember, the number of trials is how many times that is happening. How many times you're actually trying to hit the ball. Not necessarily that how many times you hit it, how many pitches you have. So in order to do that, a favorable outcome is hitting the pitch. So what you're looking for is actually hitting the pitch, and it's called a favorable outcome. The number of favorable outcomes in this case is going to be 8 because he hit it 8 times. And the total number of trials is going to be 12 because that's how many pitches he got. Now when you write in the fraction, it's just going to be 8 out of 12. And when you simplify that, you get 2 out of 3. So basically you just divide them by 4. So the probability of hitting the next pitch is going to be 2/3. Will he necessarily hit it? No. But the probable outcome is 2/3. It's more than half. So that's what this means. And that's what we're going to be working on right now. Number 1, Ramon plays outfield. In the last game, 15 balls were hit his way. He caught 12 of them. What is the experimental probability that he will catch the next ball that is thrown in his direction? Okay, again, the total number of trials is how many balls were hitting his direction, the green one. So in this case, green, we're going to have how many? Remember, this is always going to be part of our total. Part of our total. In this case, the total number of balls is right here, 15. The part is going to be how many he actually caught. In this case was 12. So what is the number of favorable events? That's the pink one. That is the pink one. Number of favorable events. That is the pink one. Which in this case is 12. What is the total number of trials? That was the green one, which in this case is 15. So what is the experimental probability that Ramon will get the next ball that is hitting his direction? Is it just 12 over 15? Remember, right here, part of our total. Now we gotta simplify this. Every time that we can simplify this, we have to. So in this case, I know both of these are multiples of 3. So my answer will be 12 divided by 3 is gonna be 4, and 15 divided by 3 is 5. So what is the probability that he will get the next ball? It'll be 4/5, and that's it. Unless they ask you to convert to percent or decimal, you can do TiVo and then divide. And in this case, you can actually multiply this times 20 times 20. The bottom will be 100. The top would be 80. So this will be 80% or 0.8. Either way, works the same. Now, if you were to divide it, the 4 goes inside, the 5 goes inside, and then add a 0, add a decimal, add a 0, bring it up, and this is 8 times 40, your remainder is 0, and you get the same answer. If they want you to convert to percent, you should know how to do this by now. Okay? Let's do another one. It says, in one inning, Torrey pitched 9 strikes and 5 balls. 9 strikes and 5 balls. What is the experimental probability that the next pitch she throws will be a strike? So this one is a little different because we know that he pitched 9 strikes. We're looking for strikes. However, the total outcome, the total number of trials is not necessarily given to us in a number. We have to come up with that. So, how many total pitches? How many total pitches? How many total pitches? I know that she do 5 strikes and 9 balls. I know that she did 9 strikes and 5 balls, which is a total of 14, right? We know that. So number of favorable events. The favorables are what? The strikes, right? The green ones. Number of favorable events. In this case is how many? 9. What is the total number of trials? Remember, this is not necessarily given to us. It's not necessarily given to you, so you gotta find it. So it's gonna be this and this together. You gotta add them up, the strikes and the balls. So in this case, there were how many? 14. What is the experimental probability that the next pitch will be a strike? So we're still talking about strikes. We're still talking about strikes. So this is pretty simple. What you gotta do is write down the fraction. 9 out of 14. We can't simplify that any further, but if they ask you to convert to percent or decimal, you can just do TiVo, top in, bottom out. Just go ahead and divide that. And then you should be able to convert that into a percent or decimal. That's pretty simple. Next one, number 3. Torrey threw 5 pitches for 1 batter. Kevin, the catcher, caught 4 of those pitches. What is the experimental probability that Kevin will not catch the next pitch? Look at the question. Kevin will not catch the next pitch. So we're gonna have to, basically they're combining the whole problem right here. The ABC steps, we're gonna do it all in one, and this is how you're gonna be doing it. So, Tori threw 5 pitches, Kevin the catcher caught 4 of those pitches. So my total number of pitches equals how many? 5, right? 5. How many did she not catch? So she caught 4 of them. How many did she not catch? This is where they're gonna throw you off. They're gonna give you the information that actually happened, and you're looking for the opposite of that. So not caught is how many? 1. Because he did catch 4 of them, 4 out of the 5. So he did not catch 1 out of the 5. So the part over total is gonna be 1/5, and that's it. That's it. 1/5 is the probability that he will not catch the next ball, and this is 20%. All right. So if there's any questions, please leave them down in the comments below. I hope that you learned something today. Again, experimental is just the actual experiment happening. So without further ado, we're going to continue talking about experimental probability, but then it's going to be about compound events. And we're going to talk that on the next video. So make sure you hit the notification bell on so that you see when the video comes out. As always, if you learned something today, make sure you give it the thumbs up button. Don't forget to comment, share, and subscribe. That is it for this one, guys, and I'll see you on the next one. Goodbye.